dice are rolled, but X is the lower number when two dice are rolled. So um, what I want you to see here is that down the first column and across the first row, the lower number is 1 in each of those cases. So there's when x is 1, it's uh, let me count here, 5, so it's 11 out of 36 is the probability of x. Down this new L region, 2 is the smaller number. So that's 4 plus 1, that's 9 out of 36. And then for 3 is this one here. You can see the pattern here, 7 out of 36. 4 is this L shape here, and that's 5 out of 36. 5 is this right here, 3 out of 36, and then 6 is 1 out of 36. Just that one there, the lower number. If it was the higher number, it'd actually be the same thing. So maybe we'll just make a note of that, because it would just be, these numbers would change order, but it would be essentially the same type of patterning that you see here. So to find the expected value, you have to take x and multiply by p of x. So the expected value is 1 times 11 over 36 plus 2 times 9 over 36 plus 3 times 7 over 36 plus 4 times 5 over 36 plus 5 times 3 over 36 plus 6 times 1 over 36. And we got to multiply that out and add it up. All right, so let me do that here. All right, so I work this out, and I get 91 over 36 as the answer. So let me try that. Should be correct. Hopefully I entered it incorrectly. Okay, 91 out of 36. All right, and that is correct. I'm going to skip 5 for now. We can come back to it. 1 and maybe 1 and 2 and 5, they're all the same. They're mean, median, and mode. They're things you know how to do, but we'll come back if we have time permitting.
Right.
Question 6 says 30 darts are thrown at a dartboard. The probability of hitting the bullseye is 0.2. So this is the binomial distribution. And the binomial distribution has an n equals 30 and a p equals 0.2. The expected value of a binomial distribution, though, is always n times p. It's very straightforward. 30 times 0.2, which equals 6. I'll just write it here. The variance for this is n times p times 1 minus p. And then sometimes they want you to get the standard deviation, which is the square root of n times p times 1 minus p. You can see how these kind of just progress, through to these calculations. But this one is just the value of 6. 7 is like 5. We'll go to 8. Calculate the expected value for the given probability distribution. So again, it's x times p of x. So your expected value here is 1 times 0.2 plus 2 times 0.1 plus 3 times 0.6 plus 4 times 0.1. What is that? 0.2 plus 0.2 plus 1.8 plus 0.4. It looks like it's 2.6 is your final answer on that. So just be comfortable doing that. Number 9 and 10 are exactly the same. Let me step them both in, and we'll just work on them. If you got a calculator handy, you can just confirm the results, but you're just multiplying x times p of x, x times p of x, x times p of x, and same thing down here. So I'm just gonna create a little thing in Excel here to do this a little faster, just to confirm the answers and get those to you. So they're giving you a lot of practice on the same thing here, which, you know, good or bad, that's what it is. 10, 20, 30, 40. Looks like the ASU finals are a little earlier this year.
Yeah, I have one this week and then like a bunch next week and then we're done. So
Yeah, it's
yeah.
no spring break and starting a little earlier makes a huge
Right,
difference.
right.
So this one ends up being 27. Let's try that, and then you have summer classes lined up or an internship or anything like
I'm
that going
going
on?
to back to the summer camp that like Sophie and I have been going to, and I'm like a counselor and like a whatever like program coordinator there.
Okay, is
So I'll
that a
be there.
paid
Yeah,
thing?
it's like a paid job slash. It's kind of
Awesome.
like a little internship too, because I'm like gonna have more like leadership this year. So yeah, I'll just be doing that. I haven't really figured out summer classes yet, but I might take a few. So
All right. So 11 is the exact same thing. We should do these though, just because they are about the same. So uh, you can tell this definitely is going to be on your exam in some way. You know, I don't know if it be a lot of questions, but you just multiply x times p of x, and that's the answer. So I'm just entering the numbers in this little thing that I made real quick to do this a little bit faster. 0 0.0, 0 0.4, 0, 0.3. All right, so the expected value here is 9 when you multiply these together. All right, 12 does transition to something different, so we'll do 12. Seems like a lot of work here, but I think we're gonna get through this pretty quickly. Let me snip number 12 in. Okay, number 12. So it says calculate the expected value of the given random variable. So the random variable is the number of tails that come up when a coin is tossed 38 times. This is a binomial distribution because there's only two outcomes, heads or tails. The probability of heads is 0.5, probability of tails is 0.5, n is 38, and the expected value is n times p for this. So 38 times 0.5, which is 19. Now it's possible, like let's just say it's at 39 times, you would get a number that isn't like you would get 19.5 as your expected value. And that, even though it's not possible, it's still the right value. Like you can't get half a heads or tails, but it's what the average would be if you did this enough times. All right, so go up to number 13, then we'll go back and do the other ones here for you. Okay. Roulette Wheel has numbers 1 through 36, and they alternate black and red. I don't know which one's black or red, but like one is black, 2 is red. 0 and 0, those are green, by the way. A bet on 4 numbers pays 8 to 1. That is, if you bet $1 and one of the 4 numbers you bet comes up, you get your $1 plus another 8. How much do you expect to win with a $1 bet on 4 numbers? So there's a total of 38 numbers. And if you bet on 4 numbers, pays 8 to 1. Okay, so your expected value of x is you have to find these two outcomes. So one outcome is you win $4, and the other outcome is you lose $1. Okay, and I think the way this is written, although it's a little bit unclear, is you have a 4 out of 38 chance of winning, and you have a 34 out of 38 chance of losing 4, meaning like if you get any of the 4 numbers, you get the $4. Any of the other numbers, you lose your dollar. So your expected value of x is your x value, times your P of X value. So it's 4 times 4 out of 38 plus -1 times 34 out of 38. So it's okay for X to be negative. And I believe this will show that you end up losing money most of the time. 16 out of 38. 34 out of 38. So this is format long. You end up losing -0.47 is your expected value. So on average, you'll lose 47 cents every time you play. Didn't like that. Okay. Oh, I gave you the wrong numbers here. It says you get back $8. So this should be 8, not 4. So that changes the numbers here. Let me get that correct value up. Minus 0.5. Minus 0.05. All right, and that does it. Okay, so we're going to go back and do the first view. Again, I'd like to just knock those out, although it seems like we've missed, okay, so we've missed 9 points, but you'll see these are really, really fast.
Yeah.
And just if you have your calculator, I just want to remind you of how to get to the places you need to find these. So you have to put the data into list in your calculator, list L1. You're going to want to put these data values in, 3, 5, 5, 8, -1, like that. And I think it's stat. Let me have to look this up again, where it is. Stat, calc, and then it's one variable stats.
How do you enter in the list?
Yeah, let me get there too. So to get that, you go to second list, second stat, which is list.
Yeah. But it just says L1, like how do I enter values?
You go down to the one below L1 and just hit the down arrow, and you should be able to enter the data in. Like hit 3, enter, 5, enter, 5, enter, 8, enter.
I'm just at L1 and then it just puts L1 like on my calculator. It doesn't go to the table.
Oh, there's an edit. I'm sorry. There's a edit. If you go to you have to go over to edit the list. Let me see if I can talk you through it. All right, second list TI 83 4. So stat enter. This is one of the limitations of this format. I can't easily just show you on your calculator. It says stat edit. Did you choose edit for that? Maybe it's
edit.
maybe it's stat edit.
Yeah, it was
okay.
stat edit.
Okay. All right. There you go. And then get the data in, and then
you do second stat L1.
Yes. Well, you actually don't know. You want to go stat calc one variable stats for the mean, median, and mode.
Okay. And then what would you put next to the frequent list?
Say that one more time.
It says list L1 and then.
Yeah, you want to choose L1 because that's where you put your.
But then it says frequent list.
You don't have one of those. Is there an option just to not put anything there?
Oh yeah, then I got it.
Okay. So the mean is your X bar.
4, I think, or no?
Probably. Let me. I'm gonna do it a different way because it's I don't have a TI to do it with, but mean, median, mode. Okay. What I don't recall is if your calculator will do the median. Let me check here. Do they have the output for this? I don't see it. So do you see the yes, this doesn't really help you that much. It helps you with the mean, which you could find just by averaging the numbers. This helps if you needed the I'll just point this out. If you needed SX, that's the sample standard deviation.
Well, I found the median
Oh,
like
good.
on the calculator.
Oh, yeah. If you scroll down, it'll give you like
Yeah,
Q1, Q2 median. Okay, what did you get for that?
5.
5.
And the
Okay.
mode is obviously 5.
And then the mode, I don't know that the mode will give you, it'll give you the mode, but it's the one that occurs most frequently.
Right.
It could be more than one value. What I think is better to do is to sort the data in order, which is kind of hard to do on your calculator because you can just visually see it a lot faster.
Right.
The median in this case looks like it's 5. All right, so that's let's do number 5 is exactly the same, but it's a different data set. Snipping that in. All right, so these values, just enter them into your calculator again if you want. I would always recommend entering it twice or checking each value to make sure you entered it twice. Make sure you enter it correctly second time. That's probably where most of your errors would occur. The mean here is 0.02. The median is minus 0.6. And then the mode is minus 0.6. Whoa, why is it doing that? What are you seeing on my screen right now?
I see 5, 0. Like I see what you put for me median.
Okay, this thing just freaked out on me. This extra monitor. Why is it doing that? Okay. So do you see these values then? Why is it doing that? Okay. Just get sorry, this thing got okay. So let me enter those values and 0.02 minus 0.6 and minus 0.6. Submit answer, and then there's one more of these. So this time the data set's a little bit simpler. It's just whole numbers again. So we got 3, 1, 12 minus 3, 0, 1. So the mean is 3, the median is 2. And notice how no number appears more than once. And that's what it actually says in the instructions. It says if every number, let me just paste this in here. It says if every number of the solution set is a solution, enter every in the answer box. That's what we're going to do, every. And you got to be on the lookout for that because that's that's the one you probably see on your exam, the exception, because these are so easy to do. You got your calculator, there are not that many numbers, so on. Okay, that takes us to the end of that homework, 100%. We'll look at 9.5. Hopefully this one's not too weird. Okay. We will be using your calculator again for this.
Okay.
Okay, so number one is it's a normal. All these are normal distribution problems. It tells you it's a normal distribution. You need a mean, standard deviation, and what you're finding between. Your calculator has these built in. So the built-in ones are going to be under stat. No, I think it's second distribution. But let me look here. Second vars, which is distribution. Let me normal distribution TI-84. Okay, see if I can find that. It's very antiquated to do on your calculator, but that is what they want. So, all right. So it says here, if you do a normal distribution, which is second vars, and you always want to choose normal CDF.
Okay.
If you choose normal CDF, you should see something like the following, where it says upper, lower, mu, sigma paste. Okay, so now your upper in your problem, your upper is going to be 66. That's this value. That's your upper. Your lower is 36. Your mu is 51, and your sigma is 10. And paste that, and then let me know what you get for
0.86638. I don't know how many it's asking.
4 decimal places usually where we go.
8664.
Okay. And that is the extent of this. Now there's a few little wrinkles we'll talk about, but it's let's see if we can find another one like that. Trying to find one that's like this, but the rest use what are called standardized scores. But we'll do number 4 next, and we'll come back to the other ones. But okay, okay, blah blah. Okay, mu is 153, sigma is 6, and they want the probability that the score is less than or equal to 147. You know that it's normally distributed, so you have to look for that wording. So you're going to do the same thing. So the problem though is that you're going to see here is that you don't have a lower value. You have an upper value of 147. You have a mu of 153, and you have a sigma of 6. And if you saw this in class, I don't even know what your instructor might have told you to do. The tables are more helpful, but you're going to use your calculator. So
well, it's not even letting me go on without putting in a lower.
Okay, so like some students do this, they do like 10 to the minus 99.
Okay.
And I wouldn't do that though. Like that's way too far away. Like you have to kind of look at the numbers and make an educated guess. So you remember this from school, from high school, and maybe previous math classes. Your mean is 147.
Right.
3 standard deviations is pretty far away. So you might go like 6 standard deviations away to get out here. Like if you take this number and you subtract 6 sigma over here, that's good enough. If you do this 10 to the minus 99 business, you can potentially run into problems on certain calculators, like where it never computes, or just a variety of things. So like in this case, if you take 6 and you multiply by 6, that's 36. Like 101 is pretty reasonable. Sorry, 111, because it's so far away in the tail. And so that would be my recommendation. If you don't like that, you could try 0. 0 is also a good value in a lot of these. But this 10 to the minus 99, you can just run into some issues with that.
Right. So 0.
Sure, 0 is great. And 4 decimal places for this, please.
0.1587.
All right, let me try that. that takes care of that. Okay, so now we're going to do 5. And so sometimes you're going to see this thing called Z instead of X. And Z is just the standardized values. So this problem, instead of it doing with X, you'll see there's a Z right there. So for Z, this is always true. Your mu is always 0 and your sigma is always 1. So this time, when you go to your normal CDF, wish we had a clean one of these that we could use each time. Your lower is minus 1.61, your upper is 0.3, your mu is 0, and your sigma is 1.
About 0.5642.
All right, let me enter that. All right, so here's another one. Have you try. So try this one on your own, please. Give me the value whenever you're ready.
About 0.1554.
Okay, so while I'm entering that, here's 2 more to try.
Um, 0.8415.
Okay, you can try the next one, please. These are a little bit harder to do if you had to look them up in a table, but you don't have to. You have technology on this. So you may want to ask, may want to make sure that you're okay to use technology in this, because you have to do it in a table. There's 2 steps, and then you subtract the values.
0.7009 for the next one.
Okay, so while I am doing that, let me snip in. There's actually one more of these kind of straightforward ones, and there's a few others now that are a little bit more difficult, but go ahead and try this one, and I'll enter in the value for the previous one.
And I got 0.1902.
All right, let me get that entered. All right, so let me go back up to the top of the lesson here, and let's kind of backfill some of these that there's that one. Okay, so there's 2 questions that we're going to look at now, and these are going backwards. So these will be a little bit harder to explain, but they're still calculator problems. All right, so again, suppose X is a normal random variable, mean of 70, standard deviation of 5. Find A such that the value of A equals 0.004, X greater than or equal to equals 0.04. So this value in red is the value that we've been getting out of your calculator. So you could just randomly guess numbers, and maybe you'd eventually find that, but that's not the right way to do it. Your calculator has an inverse norm, and it's number 3. Okay. So it's the second vars number 3, which is this inverse norm. And okay, and then you should get something that
area.
Yep, area, mu, and sigma.
Yes.
Great. Okay. So there's a few little wrinkles here. So the area that it wants is always what's called left tail. Oh. So you want 0.04 here in your area, but the calculator wants this one over here. It always wants what's left, or what's called left tail. So the left tail is 1 minus 0.04, which is 0.96. So this area is 0.96, and that's just the way your calculator works. It always wants the left value. Your mu is 70. Like, I'll just cover it up because that maybe that'll look weird later. And your sigma is 5.
Okay.
And what's your answer to 1 decimal place for that?
78.8.
All right, let me enter that and see if it's correct. Probably is. Have you seen this in class? Maybe, right?
Yeah.
Okay. Yeah, the going backwards is always harder than going forwards. So this is the same deal as the previous one we just did. So let me snip it in. So again, they give you mu, they give you sigma, they tell you it's normal, and they say right tail, the right of A is 0.03. That's 0.03. But your calculator only works with left tail. And that's why I keep emphasizing this, because it's if you put 0.03 in, you'll get a number that just doesn't work. It'll be completely wrong. So you have to realize that the area here is this 1 minus 0.03. That's your area, 0.97. Your mu in this problem is 100, and your sigma is 10.
About 118.8.
All right, it says that's correct. Okay, so there's 2 problems left. 3, actually, there's 3 left. 2 of them are the same. Let me try to think of the right order to do these in. Okay. All right, so next one here. I think you may have to get some clarity from your instructor if for this, because this is in the normal probability distribution section of this class, and you're making an approximation to the binomial distribution. So it says you're trying to use normal, but you're approximating the binomial distribution here, because you can do this with a computer with the binomial distributions. That's why it's a little bit odd to do this. So let's see, how are we going to do this here? All right. I feel like this is going to be very unclear, but there's you rolling something 100 times. That's right here. And they want to know the probability of rolling a 1. So your probability of rolling a 1 with a dice is 1 out of 6. And we talked about this in the previous problem. The previous section, the expected value is n times p, which is 100 times 1/6. That's 16.67 repeating. Your standard deviation is the square root of n times p times 1 minus p. So you can get that number. It's 100 times 1/6 times 5/6 square rooted. So we get that number. So now you're trying to find the probability that 11 is less than or equal to x is less than or equal to 16 or 17. So this is where it gets confusing. When you're approximating, you make these adjustments. So you actually end up going to 17.5 and 10.5. And if you don't know why that is, I mean, that may or may not have been covered in class. So this is a normal CDF problem. I'm going to grab that again. And this is one I would definitely want to bring up to my instructor. So, hey, how do you expect us to do this in class? So your lower here is 10.5. Your upper is 17.5. Your mu is that is that value we found up above. I would actually leave it as like 100 divided by 6. And then your sigma, you can actually just enter in calculations. It's 100 divided by 6 times 5/6. Because if you start rounding, you'll run into all these issues potentially. So let me do it here myself. So we got 100 divided by 6. Standard deviation is the square root of 6 times 5/6.
0.5618.
Let me get caught up to you here. 10.5 to 17.5. I get 0.5395. What did you get for your standard deviation? 3.72677?
Well, I just entered it like as a calculation.
Okay. Did it give you a number though in that space?
No.
Okay. 10.5. So I get 0.5395 for this.
I
X1,
think I
X2.
5. Yeah, that's probably there. I don't know.
All right, so I ended up getting 0.54 for this, which does work. There's one more of these problems like this on the assignment. I don't think these are very clear, but they are what they are, meaning they're here, and we have to see if we can know how to do them. All right, so this one you roll a die 200 times. That's your n. What's the probability that you roll fewer than 25 ones? So the ones, the probability of 1 is equal to 1/6. So your expected value here is 200 times 1/6. Okay, your standard deviation is the square root of 200 times 1/6 times 5/6, because you have to subtract that p-value from 1. So those are two numbers. Now, what's the probability that you'll roll fewer than 25 ones? So that's the probability that x is less than 25. Notice it's not less than or equal to. Like 25 is not fewer than 25, so that's why it's not included.
Mm-hmm.
And there's this adjustment that you have to make, which is a little bit odd, but it's probably that x is now less than 24.5. Since 25 is not included, you go down to the next one. I apologize, it's unclear. I mean, there's like a ton that goes into this that, we're kind of avoiding talking about. So the upper here is 24.5. Your mu is this 200 divided by 6, and your sigma is this square root 200 times 1/6 times 5/6. So your lower is now, that's where it's tricky. Like, what do we put there? And I mean, 0 is pretty good for this, because whatever you get for this number though, should be pretty far away from this, like the mu. But it might be better to go like, you see here, it keeps doing -10 to the 99. I mean, that's true. I mean, if your calculator will accept that, I would do that.
It's I think it's 0.0469. That's what I got.
Okay, let me just get caught up to you here, where I'm gonna enter it into this thing. I've got 200 over 6 square root, and then 24.5 left of that. Yeah, 0.0469 looks good to me. And it actually just says to 2 decimal places, so it becomes 0.05. They probably do that because there's all these issues with like knowing how to actually enter these values in. So let's see. It did take that. Great. All right, one question left on this assignment. I should have done this earlier, but it'll be pretty fast. I didn't realize it was part of normalizing. Okay. Find the probability that a normal variable takes on values more than half standard deviations away from the mean. So what that means, here's your normal distribution. Here's z equals 0 right in the middle. Here's z equals 0.5. And here's z equals minus 0.5. So it says more than, so it wants all of this area and all of this area. Now you've used that normal CDF a couple of times. Notice it doesn't have like an outside case. It just has a between. And that's what this means. This means between. So if you want outside, which is what you want in this problem, you want the outside of this, you do 1 minus the between. So you get that between value. Your lower is minus 0.5 and your upper is positive 0.5. Mean is 0, sigma is 1. You get the between, and then you do a 1 minus that.
Okay, that I got 0.3829, but then 1 minus that is 0.6171.
Okay, let's try that. 0.6171. All right, that is correct. So that's full mark on both of those assignments. We've got a few minutes left. If you'd like to use it, we could go to the exam review, something else. What would you like to do?
That's it. I mean, I don't even know if I'm going to take the exam, honestly. So
hopefully you don't. Hopefully you get the grade you want. So
yeah.
Great. Well, I'll send you the notes and the screen recording out shortly.
Okay, well, thank you so much.
You're welcome. Have a great day. Bye now.